Okay, I'd like to welcome you to today's seminar. Peter? Andy? Anybody?
Oh, yeah, who's in charge?
Yeah, okay.
Charles is in charge. Is Charles not here today? Ipso has announcements.
Yeah. Okay, so we only have like 1 or 2 spots that need to be filled for the rest of the semester for bringing things to share for the soup kitchen. So as usual, just follow that URL. Remember that it's case sensitive. And then also, just so everybody knows, for your birthday, or in the case of people who have their birthday during the summer, your half birthday, we're putting candy bars into your box down in the lab. So if you've had a birthday lately and you didn't know about that, go check it out and get yourself your candy bar. And then one more thing.
Come back in my box.
Yeah, sure. And then the last thing, we're going to have a brown bag lunch on Thursday, November 11th. Thursday, November 13th at 11 o'clock. So, and we're going, actually, IPSO will be providing the food for this brown bag. It's not technically a brown bag, I guess, but it will.
Will there be brown bags there?
Yeah.
Yes.
Okay. Right. Brown bags will be present. It's basically for people who would like to connect. It's just like student-to-student networking and connections, especially in terms of like, we're going to ask some of the more experienced students to come and mentor like students who have just barely gotten into the program, so you can ask them all of your questions. What classes do you take? What did you find interesting? What are you studying? What path are you on? Like, so that you can kind of get an idea of what the expectations of the program are from students directly and what their experience has been from taking classes. So don't forget November 13th at 11 o'clock.
Yeah, we're going to create an event on the Google Plus community, and we'll send that out, and you can RSVP that way.
Do we know where?
Nice.
There's a Google Plus.
That's why you need a student mentor.
Yeah, if you haven't been added to the Google Plus community, you want to get on there.
I don't think so.
Go into Google Plus and look for BYU IP&T. You'll see a community there. You can click and you can request to be added. So there are some of you we may not want to add. Don't take it first. Actually, no. By all means, that's a community where we keep people in that community even after, or keep yourself in the community even after you graduate. So there are alumni in that community you can communicate back and forth and stuff. So you'll see several of us. We try to post the job announcements in there, so that if you've graduated, you can still see those.
Yeah.
When the event is created in the Google Plus community, can we put like questions in the event, kind of like if we want to ask or prepare questions in advance?
Yeah, by all means. Yeah.
Hey, and I don't know what the plans are for seminar next week. Do you know?
AECT is the plan for next week.
I know AECT is next week. I don't know if Charles has planned having a seminar. He probably has. I'll check with him because he's running it, so I'm not announcing anything. But because we have ACT next week and people will be gone, I want to let you know that the week after ACT, so in 2 weeks, on this Wednesday, we will have one position. We'll be here presenting a seminar, and then that morning, for the IPSO brown bag. That morning, actually, we've set aside some time for that applicant to meet with you all as students without us in the room, so you can tell them the truth. And do a little morning thing with him. And the week after, the seminar will also be another applicant. 2 weeks in a row afterwards. So, yeah.
Super important question, Peter. Will there still be soup next week for those people who are in attendance?
Soup guys, I've got soup.
We have soup lined up, so I guess if people are still willing.
Charles, on the syllabus it says that next week is either you're at AECT or you get a question answer with the department chair, unless he's at AECT.
So Charles will not be AECT. He's gone this week at a conference, and so he'll be back next week.
So he'll be here, and if you're here, you do a question answer with him. It's about courses, projects, schedules, expectations.
All right. Are there other announcements? All right. Who would like to Is there anybody who would like to offer an opening prayer?
Dear Father in heaven, we thank thee for this time that we can meet as a department and have a seminar. Grateful for Dr. Wiley and his willingness to share his knowledge with us. We pray that thy Spirit will be here with us as he presents. And we say these things in the name of Jesus Christ.
Amen. I think you all know Dr. Wiley, so it doesn't need an introduction. He was here before, unless you were absent. Actually, he was here even if you were absent. So I'm going to go ahead and turn the time over to him.
All right. Back for more. You buttons for punishment? Welcome. What's the difference? After our last time together, you may be thinking to yourself that learning analytics sounds a lot like educational research.
You need this up for a reason. You're going to draw on this.
No, you want to put it down?
Yeah, there's a glare.
There's a glare. That's just the back.
Is it still not working?
Is it not working again?
Oh, the note, is the note still good?
Well, yes, but I thought they had fixed it.
We have to actually pull it down.
Replace the big mesh.
No wonder it doesn't work. You keep pulling it down.
Nice.
All right.
More impressive.
That's beautiful.
Vanna White, ladies and gentlemen. Okay. So I just wanted to clear up a little bit because this is some of the conversation we had after last time. Is that this sounds a lot like educational research? I mean, what's the difference between learning analytics and educational research more broadly? And that is that the way that people think about learning analytics is really grown out of the way people think about web analytics. If you're familiar with web analytics, so the Ancestry.com joke here is that learning analytics has its family history in the .com movement. If you're familiar with things like A/B testing, for example, it's thinking about things that people were doing in web analytics, like A/B testing, that first made folks get interested in thinking, what would happen if we started applying this to education, particularly as education is moving online and generating more and more data. Operationalizing that kind of family lineage, I guess we would say that learning analytics really focuses on what people refer to as exhaust. So it's data that's generated, not on purpose, it's data that's generated as a byproduct of something else that you're doing. So when you log into your learning management system and you're taking your class, you're generating lots of data. You're generating data about what time you logged in and what page you looked at first and where you went to next. You're generating all that data kind of as a byproduct of your interaction with the system. Nobody has set up a research study specifically for the purpose of collecting data about how often you log in. You're just logging into your class to take your class and do your assignments, and that's throwing off this kind of secondary data byproduct. And so the focus of learning analytics research is almost always on pre-existing data, or on found data, you might say. So inasmuch as we're talking about data exhaust, what are the emission standards here? What kinds of data exhaust do you throw off in your daily life when you're logging into Canvas or what's the Learning Suite or some of these other tools? So take 3 minutes, turn to the person next to you, generate a list of some of the kinds of data trails that you're accidentally leaving behind as you're working in an online setting. So try to capture them somehow, like write them down or type them in or something.
Don't check it all the time? You don't check it 3 times a day?
Some websites can do that.
Avoid material or even
How many of them are you reading? How long is it taking you?
as far as time goes, like I said,
And even if I'm doing something else, it looks like I'm in. But I don't know if they can.
All right. As you're making your way across the interwebs, what kinds of little data trails are you leaving behind? Likes and dislikes. For example,
Like on YouTube, you can like the video or dislike the video.
yes. Okay. Why can't we dislike things in Facebook? Rhetorical questions. Okay, what other kinds of data are you, footprints are you leaving behind?
We came up with a whole list here, not the whole thing.
The highlights.
Okay, well, the big thing was it'll track your IP address, which will give you your location, whether you're on campus, off campus, somewhere else.
Okay.
Through to get there, they'll also figure out, what device you're using, whether it's a mobile device or a computer, what OS you're running, what browser you're using. So, then we got into webcam spying. Are they activating your webcam to see what you're like?
When you start talking about IP address and network and stuff, I started saying unless you're using Tor, but then that's a different talk when we do the talk about Tor. Saw another hand over here.
Where you came from, what page were you at that provided a link to get you where you are now?
The
And
refer,
sometimes
yeah.
even where you went to from that page. So where you came from and where you're going.
Okay.
But not why are you there. That's right.
Where did I come from? Where am I going? But not why am I here? Thank you. Good.
We had things like assessment data, so like how many
Okay.
questions you got right or wrong, and what questions. Your participation in a discussion, when you turned in an assignment.
Yep. Okay, very good.
We had time as well, so length of time you're logged into a site, or length of time you take to do an assignment, or last time you were logged in.
Okay.
All this.
Time can be kind of dicey. Why is time dicey?
Because I walk
Switch
away and leave
tabs.
myself logged in.
Don't know they're looking
Because
at
you go to get a glass of milk and you go to the bathroom and
Do you differentiate between active time and non-active time? Like, could you see if they're actually scrolling slowly down on a screen?
There are ways to do that, but most learning management systems don't give you that.
Yeah, you activate their webcam.
You activate their webcam. So I can see we've got to have the Tor conversation up here. Yeah.
So Shiloh said that she knows her students let it time out if it ends at 59 seconds. If it ends at 59 seconds normally.
What do you mean they let it time out?
Well, so I teach for BYU Idaho online, and so I can see their activity.
Mhm.
And sometimes they'll be on the page and it'll be there for 29 minutes, 59 seconds, and I just know that's how long it takes, and it'll time out. So if I see a bunch of those in a row, they've looked at it and just wandered
Walked
off.
away.
and
Then you
gotten
know
to
it was probably inactive.
Yeah,
So-
sometimes at least.
So there are things we can do to try to clean up those data,
Yeah.
but some of them are a bit of a mess. Yeah. Yes.
Can you also track if they actually watch your video the entire way through, or if they just kind of click to different parts of the video and skin it?
Yeah, so YouTube has an API for capturing that kind of data, but the embed code that YouTube gives you by default, when you just go grab the embed code and put it in your wherever, in your LMS, actually doesn't include that. You have to turn that on and get it put into the embed code before you pull it out and bring it over. But yes, you can. Yeah.
You can look at their metacognitive strategies about whether they're checking the schedule, whether they're checking their grades a lot, how far in advance they read an assignment before it's due, so you can see what they're planning and what time management strategies are.
And then you can start to make some inferences based on that. Sure. Okay, awesome. So there's a bunch of things inside the institution, the kind of data that come out of LMS, but also grade level data, or even things like gender, race, ethnicity, home zip code. And from home zip code, we can start to infer with reasonable accuracy the
Socioeconomic.
a wide range of SES kinds of data, like your family's income. Outside the institution, we do have likes. I didn't put dislikes, but check-ins, which give us geography in more interesting ways even than IP addresses do, shares, things like that. So there's a variety of data that we leave behind, both inside and outside the institution. But let's talk about this. Let's talk about this ethics question for just a minute here. What are the ethical implications of gathering up? Let's see, if I know that this user is logged into the LMS as Rob, and it turns out I'm also friends with him on Facebook, and I also follow him on Instagram. What are the ethics of me trying to aggregate and combine and do something together with those two sets of data? Or not just that specific question, more broadly. Again, take 2 or 3 minutes and talk with your neighbor. Ethical problems with big data approaches to learning.
You're right. I was going to say, I think part of it is kind of this big thing that like people don't it's not saying if they were given the opportunity, it's just there. We do it because we want something extremely I'm willing to by doing that, they know what to do, where I am. They can show what or whatever, what your taste and so I think we're giving that data but I guess maybe an ethical might actually the value of the education. I think with big data approaches, you're going to get more data than you actually want it. And what you do with that extra data, I think has serious implications, especially when you're talking about aggregating social media stuff. The irony is that people who post stuff online on social media expect some degree of privacy or control over that. In reality, they have no control and no privacy. In fact, there's public people walking through, like, the K-school here. They could have video surveillance. You could use that as part of the big data approach. And we're expecting some degree of privacy, but yeah, it's kind of but totally. I mean, like you have, like I mean, like in my Gmail account that has how much, like if I'm signed in using Google or whatever, and they know everything that I'm searching for. Yeah, that's all right back on the way. I don't know if I can find
Were you able to come up with any ethical? I didn't make that.
Not the NSA table.
Not at the NSA table. I mean the Tor table. Excuse me, the Tor table. Okay.
Do you have a clip from Captain America 2 that we could watch? Because that was just perfect. That was about this very thing.
There are a number of movies about this very topic. I would have gone with Eagle Eye probably, but yeah.
The Net, 1995.
Sandra Bullock, classic, absolutely, yes. Okay. This is not gonna. We're not gonna let this devolve into an obscure movie reference contest, which I might lose and would be embarrassed by. Okay. More ethical issues. Actually, first ethical issue.
The big thing is the invasion of privacy. Facebook, a few months ago, somehow it got leaked. They've been doing experiments on their users without any kind of disclosure, and people were really upset about that.
Disclosing it ruins it, though.
So, yes, but a lot of sites I've been involved in as a consumer product tester or whatever over the years, up front they have the big thing that we're collecting this kind of data for research. If you don't want us to do that, don't sign up for our site. So they don't tell you about that specific study, but up front they're disclosing that your information may be used for research purposes.
I bet if you dig around in Facebook's terms of service, I bet there's some
That's
whole
what
data.
it is.
Yeah, that's why. That's one of the reasons no one reads it. Yeah.
One of the things we talked about is that, like, when you usually doing it for an exchange of some sort. Like if you put on Facebook, it's for all the reasons that people use Facebook. But maybe an ethical concern is whether or not what we're getting in return for what data we are giving is an equitable exchange.
There are places that will pay you for your data, but it's shockingly little. $3 or $5 or something for a full panel of demography.
The other side of that ethical problem with Facebook is that we expect it to be there and we expect it to be free. And so it's kind of interesting. We want something, but we're alarmed when they take something for it.
Yeah, a number of people have said, I don't have a provenance on the quote, but you don't pay for, you are the product. Yeah. It may have been Cory Doctorow first, that wouldn't surprise me. Other ethical thoughts you had? Yes?
We were talking about how what you do with the data should disclose any type of personal information for something. I mean, it's so obvious, but just people's identities.
Yep. And even when you believe you've sufficiently de-identified data, you haven't always, Ross is nodding his head. Do you want to tell the story about the Netflix competition? Do you know that story? I don't know. Okay. So, I assume people know Netflix, yes? We didn't know Tor. I mean, do we know Netflix? Okay. So Netflix ran a competition 2-3 years ago now where they de-identified a big set of their data and put it out on the interwebs and said $1 million bounty to anybody who can write a recommender algorithm against our data that does a 10% better job of recommending to people movies that they will like than our current algorithm does. Big competition, made a lot of noise, a team ended up winning, they got the money. But on the side, there was a group that was digging through that de-identified data and used ratings that people have made of movies and managed to match those against profiles on sites like Rotten Tomatoes, where they'd also rated movies, but they'd done it while they were logged in, and pulled multiple sets of data together and managed to identify some of the people in the de-identified Netflix data set. And then went on to tell you whether they were Republican or Democrat, whether they supported gay marriage or not, like a whole range of things that they probably didn't want you to know when they were rating movies on Rotten Tomatoes. That's not what they thought they were exposing at that point. I mean, of course, the flip side of this is that if you go into the doctor and you say, "Doc, my back is killing me," and he says, "Well, tell me more about it. Like, how did you hurt it? What have you been doing?" And you say, "I'm really not comfortable disclosing that to you." Then there's less that the doctor can do to help you. Or if you say, if we hire Peter as the new coach of the Jazz, and all we tell him, congratulations, all we give him is last year's record. That's all the data he has to go on, like wins and losses, and we say, make the team better this year.
You could probably do better.
You could probably do better.
No, let's take BYU. Never mind.
I was going to say BYU and use Rick as the example, but I didn't want tears in the happening in the class. So obviously there is, to the point back here, there is value to be gained by exchanging data. If you're making that exchange on purpose and you're doing it explicitly and you're telling the doctor all this private stuff because you know that he's going to use it to give you better service. If there were learning tools that would ask you questions like, can the university release all of your demography to me and I can use that to give you better advising, tell you which courses to take in what order, then you might agree to do that. But the problem is that in many of these cases, that kind of explicit conversation about here's the value, are you willing to trade, that conversation doesn't happen.
I think one challenge to a big data is you're taking big data sets and you're trying to make generalizations and group and categorize people, which can be unethical because then you're no longer seeing them as an individual. And you might sort them and say, well, we think this is the great path for you without ever meeting a person. And it's the kind of, we had the whole thing in the public school system about sorting kids and limiting their possibilities.
Then you might also not sort them and not give them any support for which courses to take, which you could also argue is unethical. So pick your unethnicity. That's not right.
I think there's also a concern a lot of people have is who's going to get the data eventually, right? One of the things with Facebook was it ended up being that researchers used the data and people thought Facebook was only having the data because they don't read through the big document. And then there's also hacks, right? So if you store my data, if someone hacks it, what can they possibly get?
Yeah, and we're definitely not going to talk about Jennifer Lawrence. So, okay. Well, let's go onward and upward here. Who's working here? So part of what I want to share with you today is who's working here, what kind of work they're doing, and give you some tips on if you're interested in this topic and would like to learn more, where you should go in order to learn more. So there are two main groups. The first is a group, can you see that kind of now? First is a group called the Society for Learning Analytics Research. Solar. It's solarresearch.org with only one R, solarresearch.org. They run an international conference every year. They had their fourth annual conference this year. You can see information about the conferences that they run over here. And all of the papers from their conferences, the conference proceedings are done by ACM, which BYU has a subscription to. So you can go log on to ACM while you're on campus or through the library proxy, search for Learning Analytics Conference, and you can read all the papers from the last 4 years of conferences. And we're going to look at a couple of them in a minute. So the International Conference on Learning Analytics. Then they do a Learning Analytics Summer Institute, which is more of a workshop-y, come kind of get your hands dirty, bring some data, or they give you some data, and actually play around in kind of intensive summer camp kind of setting. And then sticking with the solar theme, they have these little flare kinds of things they call flare, which are their little regional meetings where regional groups get together and talk about things. And they do have a journal as well, a brand new journal called the Journal of Learning Analytics, which you can go and read the current issue and things like that. They're very big on being open. You'll see there's Creative Commons licenses on the kinds of things that they do. They're definitely trying to promote people being interested in, and there's jobs in learning analytics that they post and ways to stay informed and different initiatives they have going. They have one initiative around an open infrastructure for learning analytics in terms of technology and approaches. So Solar is one group, and this is a group that is primarily a group of people who are educators first and technologists second. They're educational technologists. As opposed to the other main group that works in this area, which is the International Educational Data Mining Society, which is largely a group of computer scientists with an interest in education, as opposed to educators with an interest in technology. This organization is a fair amount older, a couple years older than LAC is, but they also have they have a conference every year. The proceedings are available online here from the conferences. You can come in and read those. Their upcoming conference is in Madrid and in June. It's kind of May, June each year. They do have mailing lists. The Learning Analytics and Knowledge group, the Solar group, also has a mailing list you can subscribe to and watch kind of updates about jobs and events and publications and things like that come through. IEDM has a Journal of Educational Data Mining. And it's kind of what you would expect. You've got people who are computer scientists who are really super fascinated by algorithms and inventing new data structures for storing and processing data more effectively. And then, oh, that didn't work the way I meant for it to. And then on the solar side, the driving questions really are more educational kinds of questions. I tend to find solar more interesting. I go to their conferences. I haven't ever been to the IEDMS conference.
EDM does tend to be very technical, and so this probably is going better.
Yeah.
Doctor, are you talking about the MOOC that's going on right now? You know about that?
Wasn't going to, but go ahead.
Yeah, so there's on edX, this is the start of the second week.
Yeah.
There's a MOOC that's running, and it's data analytics and learning.
Learning, data, and something.
Yeah, so, but the guy who's running the MOOC is George Siemens, who's the head of,
one of the
kind of
founders
founder of Solar.
Yeah.
And then also Ryan S.D. Baker, who's the head of the EDM. And then Carolyn Rose, who's the head of Learning Sciences. They're all kind of doing this MOOC and talking about different tools. So it's pretty cool.
Yeah. And there's a mailing list you can join. Like I'm on the mailing list for the MOOC, just watching things go by, but not participating in it at a super high level. But in terms of interest, if you're interested in this topic and looking for meetings to go to or wondering where can I go get papers to read that are interesting or watch videos or things like that, these are the two places that you would want to go for sure. Questions about either of these? This is sort of the AECT for you if you're into learning analytics. Next conference is in New York in 2015, in March. All right, so based on the conversation we had a minute ago about emission standards, about the kind of data trails you're leaving behind without even trying to, based on that list of data that you just brainstormed, what kinds of questions would you ask if you were going to do some learning analytics work? Or what kinds of questions do you wish someone else would ask who's doing learning analytics work? Based on the sort of data that are available, what kinds of work would you do in the space? Again, talk to your neighbor and generate an interesting question or two that you can share with a group.
It's like, how long are they spending our...
We'll decide how it
I think I would like to try and reconstruct the cognitive process. Like, what are they thinking? Like, how, like, we have a problem. How are they, like, what behaviors are they show us how they're thinking. Not necessarily like what they're thinking. Well, see, you know how they're thinking as a practitioner, like if you were teaching construction, you can see, like, so for example, I teach physics, so I can figure out that my students are misunderstanding about this type of problem in the wrong way, then you can start instruction or some sort of or if you find patterns, we think about some problems in this way, and to like that's kind of you can more a good point. If it's not there, then you can be making the wrong inferences from that. So you can be trying to emphasize what you're doing. We don't have all that. There's going to be a trail behind what you want to do with data, what data you're collecting, how you're collecting it, and what you're going to show. Right. It's typically a breakdown somewhere along the chain of this is what I think I'm getting, here's what I'm really getting. Especially if it's like the data
Stop the curiosity, stop the questioning.
And that might be
what'd you come up with? What would you want to know?
Well, we've had a good conversation here. It's not called webcams. But basically, how does that relate to their learning outcome? How are they doing on the assessments?
Okay.
And what's the interrelationship between those two?
And I think in many ways that's the most fundamental of all the learning analytics questions, right? It's people trying to
What we
ask.
had is the path that they go through a learning management system, for example, to see if they're constantly doing this roundabout way to get to certain areas.
Mm-hmm.
So then you could change the design to better suit so they don't have to go in these roundabout ways.
Okay. Yeah.
Kind of go more specific. The library did kind of a push to study in the library, you know. But you could look at the IP addresses and the location where people are studying and compare it to other information to find out, okay, well, actually it wasn't better for people to study in libraries, or it was, you know. You could find out if off-campus was better than on-campus. It's probably not.
That's very specific. There's a dissertation hiding there.
Not mine.
Not
It's not involved there.
No.
It's up for grabs.
Any other thoughts? There's a lot of very animated conversation. Come on. Please.
Thomas thought that maybe we could find out who the best professors were based on...
Isn't that what Rate My Professors for?
Yeah, think of all the data we have there. Let's use it.
I was thinking about...
No, I've never been awarded a chili pepper. Who said that?
Peter's gonna come
So sad.
Took a workshop on learning analytics.
Go ahead.
I was wondering if you can look at like some students are skipping these activities but still doing good on the actual assignment, and maybe those students took a certain class from a certain professor, or the students who are doing all the assignments but not doing very well maybe took the same class from a different professor, and being able to see that, you might be able to see like maybe this professor isn't because he's not the expert in that class, we should only have one professor teach that class or something like that.
The effect of who you take your prerequisites from on
Right.
Sure, Andy loves that idea. Yes.
It's interesting that we're dealing with very gross-sized things that are counted, lessons completed, things like that, or very detailed kinds of things like which website did you visit, that kind of thing. Where did you come from? Is there some set of objects that result in countability that have to do with instruction inside of the lesson construct? What can you count inside of a lesson that's worth counting? If I was an instructional designer, that's the question I'd be asking. What are you counting?
Well, go ahead and make your Moneyball comment.
Oh, well, there's this cool book. If you haven't read it, you need to read it now. Caveat, warning, it's got some swear words in it. It's got some swear words in it. But the thing is, these guys were, the leagues were, for years and years, were keeping statistics on their players.
The baseball leagues.
Yeah, the baseball league. But some guys came along and found out that they'd been keeping the wrong statistics, and so the Yankees, which had bazillions of dollars, were hiring all these big-name guys with all the big statistics. The Oakland A's came along and said, well, we don't have a lot of bazillion dollars. What we've got is a little bit of money, but if we can hire some three-legged dogs and some kangaroos with broken tails that won't stand up straight, we can patch together a team that can almost win the series. And they did, because they knew with these different statistics they were looking for, they could get a player on the cheap to play on a really excellent team that just rose in the standings. They know when to make a trade and what guy they wanted, what person they wanted. So taking the low-hanging fruit of the data that's just available and the traditional categories is a big mistake. That's what I'm saying.
Could be a big mistake.
I'm saying it is.
Okay. So for Indiana Jones fans, you might be digging in the wrong place. Yeah.
And that's, I agree with that. If you're just taking the data that's available, that could be a mistake. You got to look at the right data for what you want. Along with that is you have to look at the assumptions that go with the questions you're asking. So, for instance, when you're asking which is the best professor, or you see this student come along and they don't know certain things, and then you bring it back to what courses they took before and which teacher taught that, you're assuming something about that data, that it's the professor that makes the difference and not the student, for example. And if you don't analyze the assumptions that you have with the questions and the theory that revolves around that question in terms of what data is important to collect, that's a mistake as well.
Other thoughts? Well, I want to show you two examples of some fairly recent work. First, this paper by McFadden and Dawson, Mining LMS Data to Develop an Early Warning System for Educators, which is looking at relationships between what they did in the LMS and whether they're succeeding or not. I'll pay you the $5 after class. Thank you. Let me see if I can find it here. Here we go.
Dave, this is mining data that's already there. They're not doing anything else to it, right?
Yeah, they're just digging around inside the LMS, looking at LMS data. Come on. Well, that's even worse. All right. Really? This paper is depressing in a wide range of ways. Actually, I'm having a harder time controlling it in that full screen than in this one. Of course, I'm skipping over all the interesting part, which is the part that Randy was just talking about all the assumptions that they're talking about, and the fact that more data are available, and which data should we look at. And anyway, here are the research questions they're asking. Which LMS tracking data variables even correlate with student achievement? So this is an initial kind of an exploratory study of saying, what is there that's in there that even correlates at all? How accurately can we use those to predict who is going to fail and who's going to pass a class? And then they also have another set of questions around student communication patterns, and can students' communication patterns contribute to their understanding here as well? Now, I'd encourage you, of course, to go back and actually look at this later. And as I said, BYU subscribes to ACM, and you can find the paper there because it was published there. Here are all the course tracking variables that they selected for analysis. So total number of logins, total time online, mail messages read and sent, discussion messages read, posted, new discussion messages posted versus replies posted, how many times they used different tools like the search function or looked at my grades or my progress, how many times did they go to the chat area, how many files that the teacher had posted did they download, how many assessments did they start, how many assessments did they finish, etc. And then here, where did my pointer go? Here, descriptive statistics for a range of things like how many people, so 118 people completed the class, average number of online sessions per student per term, was 153 with a standard deviation of 77. It's good that you're all laughing. That means you did okay in your first statistics class. Very good. So here's some descriptive statistics. I do love this point that they make. As previously highlighted by Morris et al., the research does to some extent appear to be documenting the obvious. Students that are engaged and discursive students are more likely to complete the course successfully than their less interactive peers. So here's some scatter plots of things like final grade versus the number of times they logged in. That's definitely going up and to the right. Number of files that they viewed versus their final grade, that's definitely going up and to the right. And then here's a big table sorted by correlation, simple correlation between these different measures and their final grade. And you'll see the very top best predictors are total number of discussion messages posted, total number of online sessions, total number of time online, number of files viewed. And you'll be surprised to know that in position 1, 2, 3, 4, 5, number of assessments completed ranks 5th. Like, if you're not completing your assessments, how are you passing this class? I'd like to know.
You're posting discussion, because clearly...
Posting lots of discussion messages. But here's something interesting to your metacognitive point a moment ago. Negative correlations for number of views of announcements and number of visits to the My Progress tool. The more they checked on their progress, the less likely. Now, I'm not saying it's causal, it's just a correlation, but interesting to see. They did a fair amount of social network analysis in this paper, looking at, this is the instructor in the middle, and each of these other nodes is a student in the course, and these arrows are people replying to each other's course discussion forum posts. And you can see that there are a certain number of students who never received any communication except from the instructor. They're completely isolated socially in the online course. That's not going to bode well for them further down in the paper here. People like to talk. Here you go. As shown in Table 4, the best predictive model of student final grade is a linear combination of only 3 activities. Total number of discussion messages, total number of mail messages sent, and total number of assessments completed. And they give the regression equation and everything, but the point here being, coming along and wanting to actually use this model to predict who's at risk of failure, by which we mean receiving a final grade of less than 60%. Their prediction accuracy is, on average, about 74% of the time they can accurately predict whether you're going to fail or not based on a model that uses those 3 variables. Now, there are a wide range of conversations we could have about that finding, but we're not going to have them. We are instead going to look at something else. I want to show you this other paper as well, and we're almost out of time. I apologize. So this is techniques for data-driven curriculum analysis. Who was it? Hiram made the comment about if people are going through the course in a certain sequence and maybe going backward, there are things we could learn from the data, maybe about how to improve the design of the course. This is quite interesting, I think. This is looking at 12 years of data of students in a computer science program. And these boxes are all the courses that are required to take in the program. This is the curriculum, as it were. Blue are the basic science courses, green are the humanities courses, and yellow are the actual HCI and software engineering and database and programming language kinds of courses. So the first thing that they do in this paper, and of course I'm skimming over this at a super high rate, is they went through the literature and found some techniques other people developed for estimating the difficulty of a course. And then they applied those techniques to this full list of courses, and you can see in terms of where the mean is, the difficulty of the algorithms analysis course is quite a bit higher than the difficulty of oral and written communications techniques. And they generate a big table here somewhere. Here we go. Showing the, you know, how skewed these distributions are, giving you kind of basically a difficulty rating of each of the courses in the program, from operating systems and programming fundamentals and things down to oral and written communications and ecology and environmental education and something else. This is, we're going to talk a lot about visualizations next time in the third Learning Analytics workshop. But, you know, this is showing, this is the darkness here is correlation coefficient, so the darker, the stronger the correlation. And these are between the correlation in grades between these classes pairwise. You can see there's not a lot that's particularly interesting going on there. But then they started looking at some interesting, things here. This is the result of an exploratory factor analysis where they looked at student grades in these courses and tried to organically cluster the courses together based on what the data were telling them. And you can see, so blue, all the courses that are in blue kind of had a high factor loading on the first factor. The yellow ones are a second factor. The green ones are the third. They go on to name these. There's a basic training factor. There's an advanced CS topics factor, a client interaction factor, and a programming factor. The fifth one was a bucket that a lot of other stuff fell into. But it's interesting as they do that analysis and they group those courses up, and then they go look at dropout and enrolling paths. Back to, I think it was Hiram's point. You know, so they looked at, as students come into the program, students who drop out of the program, what pathway did they take on their way to dropout? And you know, they drew a line at point 3 here and didn't give the rest of these pathways. But you can see they're all pretty short. And this one is physics A, drop out. Differential calculus, drop out. Programming fundamentals, drop out. Integral calc, physics A followed by differential calc. Linear algebra, differential calc by integral. The thing that's interesting about this, you look at these 10 most popular, however many of these